Hello, welcome. My name is Simon Timpley from the International Food Safety and Quality Network. Welcome to edition 83 of the Food Safety Fridays webinar program. We've got a fantastic audience today. We've got, I think, last count, 1,750 people from all over the world joining us today for today's topic, which is determination of preventive and control measures in food safety with George Howard from Safe Food 360. Safe Food 360 are one of the sponsors of the Food Safety Fridays webinar program, along with Trace Analytics, AIB International, and Metal Toledo. These kind of organizations support this program and bring you regular free education and PDF and the PowerPoint and certificate of attendance. Absolutely fantastic for free, but obviously supported by our kind sponsors. And CEO of Safe Food 360, George Howard, today's speaker. So, are you there, George?
Hello, Simon. I'm here.
Welcome, George. Nice to have you back. Can you hear me, George?
Yes, Simon, I can hear you. How are you?
Yeah, I'm great, thanks. And are you back at home in Dublin today?
Yes, yeah, we're back in the office here in Dublin. Just about to finish the week out, so looking forward to that.
Very good. Well, if you'd like to get your slides ready, George, I'll just have a little chat to the audience. Ladies and gents, for those of you who are not familiar, we've got a sidebar there. Feel free to type in your chats, comments, say hello to each other, get to know each other, ask your questions. We'll pick through them at the end. I'll be back for the Q&A later. Yeah, I think that's it for now. At this point, I'll hand you over to George. There we go. Yeah. Okay, George, you go ahead.
Okay, Simon, thanks. Hello, everybody, and thanks for joining us today. The subject for today's webinar is the determination of preventative and control measures in food safety. This is quite a specialized, I suppose, or focused area of the broader food safety management framework, but it is an important one. It frequently is the area which can present a lot of confusion for many people for various reasons, the language used, the terminology, and we're going to just talk a little bit about that and maybe clarify it and try to just get to the essence of what control measures are, why we use them, and the role they play in food safety management. So just the agenda for today is a brief introduction about control measures. But I'll talk a little bit about control measures and their relationship with risk, not too much. We're going to really define clearly what a control measure is. Very important to understand what a control measure is in order to use them and apply them correctly in the management of food safety. And we're going to do kind of a review of the type of what we call determination models or decision trees, usually as they're termed, when it comes to looking at HACCP and when it comes to looking at preventative control plans under FSMA. So that's just generally what we're going to do. The working end of the presentation, the benefit, I suppose, of the presentation are those determination models, and so we'll take a little bit of time on them. And but before we get stuck into that, guys, some of the models we will look at today are quite detailed. Some are very simple, but don't even attempt to try and absorb them or fully understand them today. We do have, supporting this webinar, a number of white papers and other references which you can take a look at afterwards if this is a particular area causing you difficulty or pain at the moment. So that's the website address, safefood360.com, free resources. And there are two particular white papers just to draw your attention to. The first of them is Determining Control Measures in HACCP. Now, the material there, the guidance there is applicable to all control measures in the HACCP plan. And then we also have a nice supporting white paper around how to design a CCP monitoring program. It's a little bit more technical, a little bit more detailed, but certainly both those white papers together will provide you all the supporting information that you need for this particular presentation. So don't worry about the detail too much, guys, as we go through it. You can always just download these. They're free, and you can browse them at your leisure. Okay, so just a brief introduction to this whole area of control measures. So as we're all aware, I mean, most of us will be aware that HACCP has been around for quite some time in one form or another, and we know it to be a risk assessment and, in effect, a risk management tool. Built into it are various principles which are designed to help food businesses really identify specific hazards, those things that may be present in the food product that can cause some sort of harm. Not all hazards need to be considered high risk, but we do need to determine the significance of the risk as part of our HACCP. And flowing out of that, once we know how significant the risk is, we usually need to make a decision. Do we need to have in place some sort of control measures to manage that risk? And most of the standards, like the Codex, say that you should develop control measures to address those risks where appropriate. And really, in essence, to do that, you really have to have a clear understanding of the fundamentals of food safety and food safety management, which we'll touch on very briefly now in a moment. But there are some issues around this whole area of control measures. A lot of it is unnecessary, but arises from the fact that a lot of terminology and definitions are used in various standards, which can cause confusion. So when people talk about operational prerequisite programs and control points and so on, what exactly are they talking about, and am I addressing that, or do I indeed need to address it? So we're going to demystify a little bit all the terminology and help you a little bit in that regard. One of the other issues which a lot of companies struggle with is the use of determination models or decision trees. Codex and others do provide examples, but I think a lot of us will know from experience that when we go to use them, they often cause us slightly more confusion than they do clarity. And in some cases, if we follow these models faithfully, we can often end up with what we know to be the incorrect decision. So they are guidance, of course, and you're not meant to take them or be a slave to them. But that doesn't take away from the fact that they can often be very confusing to use these particular models. So we're going to talk about and take a look at some of these determination models and how they can be used. Okay, guys, I'm going to just spend a few seconds on talking about the fundamentals of food safety management. You may ask, why do we need to do this? Because we're only talking about control measures. But it's very often the case that the lack of understanding of how food safety works can prevent us from determining appropriate levels of control. So I just have a graphic slide here, no text. This presentation, guys, is very light in text because the white papers will fill those gaps in for you. So the fundamental nature of most food safety management approaches, particularly in manufacturing, is the step, or what we might call the process step. So this is a particular step or action or a stage in the process, a particular process that might be taking place, like cooking or packing or whatever the case is typically termed the step. And that becomes our focus point. So we want to isolate each of those steps, and we do a hazard analysis on it, or we seek to identify what hazards, if any, may exist around that step that we need to take into account when it comes to food safety management. So again, most of you will be aware of this process, guys, and compiling that list of potential hazards. And once we've done that, we are usually requested to do something called risk assessment on those hazards, those individual hazards, at that process step. And what that really means is asking a couple of questions: is, well, how likely is that hazard to occur? And if it does occur, what's the likely impacts, whether that be on the consumer or indeed on the business's reputation, the goodwill of the company in the marketplace, the company's compliance level, and so on. And risk assessment normally gives an expression of the significance of the risk. So is it important enough for us to think about it and do something about it, in fact? And flowing from that, we get these control measures. So we seek to identify the appropriate level of protection that we want to offer the consumer. And that finds its working expression in the form of a control measure of some sort. Control measures could be as simple as a metal detection unit online. It could be inspecting and testing for the presence of hazards, cooking, pasteurization, sterilization. There is quite an extensive list of potential control measures and monitoring of those, in fact. And finally, best practice says that we should validate those control measures. So are they capable of achieving what we want them to achieve? And that's the question we ask there. So how best do we identify the appropriate level of control and therefore the appropriate control measure in this very simple but very clear model of food safety management? Okay. So hopefully that model is of benefit. It just clarifies how food safety works. Of course, it is in reality slightly more complex, but I think that distills it down quite well. Okay. So before we move on to look at control measures in more detail, I just want to talk a little bit about risk itself. Guys, I'm sure most of you have a very good understanding of what risk is, but that's just a recap because it's important. No point in putting controls in for something that's low risk or has no risk. No point in putting a control measure in for a high risk hazard when that control measure is not the appropriate one. Okay, so according to the World Health Organization, the risk really talks about it's a process essentially of evaluating scientifically, if possible, the known or potential adverse health effects which can arise from humans being exposed to a particular hazard. Okay, so in plain English, what that actually means is that you are taking a look at a hazard that may be there, or you're certain is there, and trying to figure out what is the likely impact on a human should they be exposed to it at certain levels. Now, most of us are well familiar with this model. So this is our standard probability by severity model that we use in HACCP analysis and in prerequisite or preventive control plans. So probability obviously is the likelihood or the frequency at which the hazard will occur. And then when you take the other factor in place of severity, so with severity you're assuming that it has occurred, what is the likely impact on the individual or population who are exposed to it? So these two factors, probability of occurrence, severity of impact, give us an expression of risk, and that can be high, medium, or low. And you can see there, guys, that's the pretty standard kind of matrix, 3 by 3, 3 by 3, or 5 by 5. It doesn't really matter, as most models seem to follow that type of matrix format. Okay, so what are control measures? I'm going to give you a very simple definition. A control measure then it's a food safety action or activity that can be used to prevent or eliminate a food safety hazard or reduce it to an acceptable level. So in other words, it's something that you can actually do, which, if it's conducted appropriately, will have the effect of either reducing or eliminating that hazard to what is termed an acceptable level. Now, what that level is needs to be determined, and it's open to a lot of interpretation, and ideally should be scientific. So a control measure is something that you can actually do. It can be like a visual inspection. It can be a test of some sort. It can be say a process that's applied to the product at some point in time that has the result of addressing and controlling that hazard to an acceptable level. So note there, we're not talking about, in all cases, the elimination of a hazard, because sometimes that just may not be possible. And in fact, in most cases, it's not possible, practically speaking. Okay, so what kind of control measures do the standards mention? Okay, so I'm going to talk a little bit about the standards that most of you operate to and work to. So let's just take the first one. Let's say ISO 22000. So if you do have time and you're that way disposed, you might want to read through these standards, and you will notice that they all seem to talk about control measures in a slightly different way. So the ISO talks about PRPs, or prerequisite programs. It also talks very clearly about operational PRPs. What is the difference? And it also mentions CCPs. Now, it's interesting because if you do read through the definitions in the ISO 22000, you probably will, like me, struggle to see what the difference is between an operational PRP and indeed a CCP. It's not really actually that clear what the difference is. However, there would appear to be in the minds of the ISO that there is some sort of difference. But you may be interested in actually doing that. Just open up the reference section and read those definitions. Okay, if we take a look then at the FDA's FSMA rules, these are rules which have been recently introduced for preventative controls in human foods and animal foods. They have introduced this new term called preventative control or preventative measure, and they do include CCPs in that. And again, it's pretty much standard definition. It's something that you can do, you can apply to the process to exercise control over the hazards that exist, where there are significant hazards. TESCO standard talks about PRP and CCPs, just as an example. The BRC, very similar. The IFS then, this is with the German and French standard, part of the GFSI schemes, talk about things called control points. So this is, again, slightly different terminology, and if you're working under that standard, it's something you need to be familiar with. Let's just go down under now to Woolworths, the largest retailer in Australia and New Zealand. They also talk about control measures and CCPs, and then also this thing called the QCP, or what they call a quality control point. So again, you will have to ask the question, well, what's the difference between a CCP, QCP, and so on? The point of this slide, guys, is just to really underline the main point that control measures, preventative control measures, are often referred to in different ways in different standards. And I will be making a final point at the end of the presentation, not to get too hung up on these differences, but I think it is important that we understand them. Okay, so why do we need control measures? Well, control measures are typically used to eliminate and reduce a risk from a food safety hazard to an acceptable level. So we've already made that point clearly. But this can often be referred to as risk mitigation, so mitigation of the risk and its impacts. And control measures are effectively used to do that. So they're used to mitigate that risk. But typically, and it's an important point, because we spoke about the probability by severity gives us our risk. Control measures usually only impact on the probability of occurrence of the hazard. So that's the likelihood that it will occur. And seldom will they ever alter the actual nature or severity of the hazard. And that's important. Salmonella presents the hazard it does, the character of it, and that's just a fact. All we can control is the likelihood that it can occur, rather than change the nature of that particular pathogen, if you understand the point I'm making. So mitigation then kind of follows this kind of model. So we have this thing called risk. In the absence of controls, the risk increases. So if we attempt to produce food products without control measures, just taking the inherent risk that's offered up by the product and the process, well, it's reasonable to assume that the risk increases in the absence of any control measures. However, if we do apply controls, or we have the presence of controls, we typically see a reduction or a mitigation in the level of risk. And that's, again, a very simple model, but guys, I think it does explain clearly why we use control measures and why they have to be put in place. Okay, so next slide is just going to talk a little bit about the types of control measures, and you'll be familiar with most of these terms, or you've certainly come across them at some stage. So let's just put them up there, and let's just speak briefly about each of them and describe them and try and identify the differences, if any, between them. So, the king of all control measures, the one we all know, is the critical control point. This obviously emerged from the Codex standard for HACCP. Kind of took its origins from FMEA, so that's kind of tool that's used generally in production and processing to identify likelihoods of issues arising. Okay, so definition is a step, so that's the process step, if you like, or activity, at which control can be applied. That's important. If you can't apply control at the particular step, you cannot have a critical control point. It's by its very nature. So it's a step at which control can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to acceptable level. So what we're saying there is that at that particular stage in the process or that particular activity, if it is to go wrong, you're reasonably assured that it will result in some adverse impact in the marketplace with consumers. So it's pretty certain, albeit not 100%, but you are reasonably assured that something unwanted will happen in terms of food safety. So that is your critical control point. You need to get it right, and you need to get it right all the time. And if you don't, you need to know about it. Yep. Okay, next one then, prerequisite programs. So again, most of us will be familiar with the PRP, as it's more commonly known. And the PRP is basically, it's the basic conditions or activities that are necessary to maintain a hygienic environment to produce safe foods, just to give you a slightly abridged version. So what that's saying is, without certain general activities and controls being put in place within the food business, over time, you're going to get issues. So, I mean, the obvious ones are cleaning, things such as pest control, maintenance of your equipment. So while they don't relate to any specific step or activity in your operation, they're more generalized. Where they're not conducted correctly, you can be reasonably assured over time that they will present issues. So time is a critical factor, guys. In CCPs, we're saying that we're pretty certain that there will be an immediate issue or imminent issue. As we're with general prerequisite programs, we're saying not necessarily going to happen immediately, but pretty certain over time. If we don't, get it right, something will happen as a result. Next one up then is operational prerequisite programs. So here we have prerequisites, and now we have a thing called operational prerequisites. And again, a lot of people struggle to really, define what the difference is between the previous two. But probably the best way to describe it is that it's probably lies somewhere in between CCP and a PRP. So with a CCP, we know we're focusing on a particular step or stage in the process, and we know that if something goes wrong, we're going to have immediate issues. General PRPs, again, not focused on any specific step in the process, but over time, we will get some problems that we need to deal with. Now, the operational prerequisite, while it's not critical, while it may not be an immediate issue arising from its failure, it does have the character and nature that it applies to a specific stage in the process. So let me give you an example. Metal detection, for example. It may not be absolutely a critical step for some processes, but it does focus on one particular stage in the operation. It is by itself designed for that purpose. So in that regard, its difference is that it's not generally applied, like cleaning, throughout the operation or plant. It has a focus and a particular role at a particular stage in the process. But it's not critical in nature like a CCP. You can get away with a little bit on this, but as compared to the CCP. Okay. Control points, again, used in IFS, and they define this as any step at which biological, chemical, or physical factors can be controlled. It's a very general definition. It's probably more aligned to the OPRP than anything else, and but that's typically how it's described. And then finally, the quality control point, or QCP, won't be of much relevance or interest to anybody outside of Australia and New Zealand. Seems to be a particular thing the guys down under like to have. And so it's a process step at which control is required to prevent or eliminate a quality issue as opposed to a food safety issue. Okay, so again, it's probably more akin to the operational prerequisite program, but focus more on quality related matters as opposed to food safety matters. Okay, so just a quick slide, guys, to show you where control measures kind of fit into the overall framework. And again, so this is like your HACCP plan or doing your PCP development. So you start out with your hazard analysis, your risk assessment, you determine the significance of the hazard. Okay, so that's important. Not all risks are equal. Not all risks need to be addressed in the same way. Low risk things can be set aside, and the focus can be on medium or higher risk hazards. So that's called the significance of the hazard. So we want to take a look at it, and then we can move forward to determine what control measures, if any, are required. We then set out the plan for those controls and validate them to make sure that they're appropriate and they do the job. And that then results in our HACCP or our PCP plan. Key points then, this is what we're looking at here, is that determination stage that may include those CCPs, PRPs, operational prerequisites. The key point here is, guys, that most companies utilize a decision tree model or a determination model at that stage, and that's now the focus of what we're going to look at. So we're going to term this determination models, but for most of us, we know them as our old friend, the decision tree. So a decision tree, just to explain, is a series of logical questions which are answered by the user to arrive at some defined outcome. Excuse me. There's typically a very clear logic behind it, and they do take a bit of time to actually consider and pull together. There are various examples available, including the Codex one, which is widely used. In this case, the decision tree as defined outcome is really a clear identification of the control measure that's required, or indeed no control measure may be the output, and usually is. Now, these decision trees kind of come in a few levels. The first is no model. So it is a case that some companies don't utilize a decision tree. They rely upon their knowledge and experience to decide whether a control is in fact required. Nothing particularly wrong with that. There is no standard I'm aware of that dictates that you must use a decision tree or model of some sort. So that is perfectly legitimate and is employed by some companies. You do very often see it in the US standards for different commodities, risk assessment and determination of controls, which don't employ a particular model. Just moving up, then we have a very simple model where these simple models are designed to determine whether a CCP is at play or not. So they're simple ones, but they're effective in terms of focusing you on the critical controls, which are obviously the most important. And we'll show an example of that in a moment. Moving up the levels again, we have the Codex decision tree, which is probably the most widely used decision tree globally. Again, it's a relatively simple model too, and it does have the primary focus of determining whether or not CCPs are present or not. And then we can have very comprehensive decision tree models, which we'll show you one of these now shortly. And the model, again, guys, is available via the white papers. So don't worry too much about trying to capture it during this session. It will be made available to you later on. But before we come to that, just in a slightly tongue-in-cheek fashion, The great thing about these decision models is they do help us, but very often reality comes home to play. And in all my years working in the food industry, putting together HACCP plans, I think a lot of us have come up with this kind of unofficial decision tree which we need to operate. But I think it's something that we need to avoid, and I think auditors are getting more sophisticated, as the years go by, and less likely to dictate to us what we need to do. But for most of us, our decision tree can sometimes look like: is there a hazard at this step? Which is the first question. If the answer is no, that's fine. It's not a CCP, which is great. However, there is a hazard. We say yes, and we move to question 2. So does the certification auditor feel that the step should be a CCP? And if the auditor does feel that, then typically it becomes a CCP, whether or not it should be. If the auditor doesn't feel that, then we usually go on and ask a second question. Do our largest customer, who pays the most money to produce their product, require us to have this step as a CCP? And again, if the answer is yes, it is a CCP. If the answer is no, we ask, final question, are we ourselves unsure as to whether or not this particular step is a CCP? And if we are unsure, it becomes a CCP, just to be sure, because we want to make sure we don't get caught out. And if the answer is no, then we're pretty happy it's not a CCP. Now, guys, this is flippant, but I think it does reflect the reality of how a lot of companies determine the control measures they have in place. In reality, we can't sometimes avoid it. If our key customer says it should be a CCP, well, then it is going to be a CCP. If the certification order comes in and pretty much tells you you need to have a control of a particular type in place, you're not going to do too much arguing over that fact, lest you lose your certification status. Okay, so as I say, guys, slightly tongue-in-cheek, but I think does reflect a lot of the reality behind how control measures are put in place. However, we would and prefer to use a more objective approach, and here is the simple model which is typically employed. So we do a hazard identification and analysis, we do a risk assessment, and then we determine the control measures. Here's a simple model. 3 questions. Question 1, is there a hazard at this step? So we're assisting the HACCP team or the risk assessors by presenting to them a clear question. And the strength of these decision trees is they normally have a yes or no output, which most of us can relate to. And this is particularly important where the skill levels or the knowledge of the assessment team may not be that sophisticated or inexperienced. Okay, so question 1, hazard analysis. Is there a hazard at this step? Yes, there is, or no. So let's take the no answer. In that case, then we can control it as a quality issue. So we don't need to control it as a food safety issue. However, if there is a hazard at that step, we ask a second question. Is the hazard significant? So if it is significant, if it's not significant, again, we can control it as a general PRP or some sort of general control measure. If it is significant, then we can go on to determine whether or not it should be a critical control point. If it doesn't need to be a critical control point, again, we can use a general control measure. However, if it is a step that needs to be controlled for criticality, then we call it a CCP. So this is a very basic model, guys. 3 simple questions that need to be answered. Effective enough, but seldom, I think, would meet the needs of most food companies these days. Okay, but that's a simple model. Now, just to move on to the next level, which is the codex model. Again, as I said earlier, it's a relatively simple model, but it kind of drills down into a bit more detail, challenges the risk assessor a little bit more to think about the nature of the hazards and the risks at play. So let's just go through the questions. Question 1, do preventative control measures exist? Okay, so what it's saying here is, do you already have something in place that may mitigate the risk arising from this particular hazard? Okay, so if there are no control measures in place, you're forced to ask an additional question. A very simple and obvious question is, well, should there be controls in place at this step? If the answer is yes, then you need to go back to the drawing board and you need to modify something. Something needs to change somewhere, and that could include modification of your process, your formulation, the processing technology itself, or something. Okay, so I think they're quite valuable. Codex kind of do add value in terms of this particular guidance decision tree. Okay. Is control at this step necessary for safety? No, it's not. So in that case, it's not a CCP. You don't need any extra controls, and you can stop there. However, if you do have preventive controls in place, then you can go ahead and ask the second question. Is the step specifically designed to eliminate or reduce the likely occurrence of the hazard to an acceptable level? So you can see here, guys, we're talking about a step in your process, and the terminology being used is to eliminate or reduce the hazard to an acceptable level. Okay, so we answered that question. Yes, the step is in fact specifically designed, and that tells us straight away that this is a critical control point. So examples could be a pasteurization step, sterilization, cooking, or something of that nature. So it's there specifically to eliminate a particular hazard, and other than that, serves no other food safety function. In the absence of that step, it's quite likely that pathogens will survive and they will cause problems in the marketplace. However, if the step is not specifically designed to eliminate or reduce a hazard to an acceptable level, you ask another question: could contamination of the identified hazards occur in excess of what you would consider acceptable? So this is kind of a more generalized contamination issue. The answer is no. Well, that's fine. It's not a CCP, so therefore you can stop. Don't need to go any further. If the answer is yes, general contamination could arise. It's then asking question 4, will a subsequent step further down the process address the issue? So there's some quite very, very good logic at play here by Codex. So they're accounting for the fact, well, look, the step is not specifically designed to eliminate the hazard, but the hazard could cause issues somewhere else. And then the question is asked, well, if it does cause other issues, is there a step further down the process that will pick that up? That could be further downstream in the manufacturing process, or indeed could be in the marketplace via normal and accepted preparation by the consumer under clear instruction. Okay, if the answer is no, there is no step further down to address the hazard, then it has to be considered a CCP in that case. However, if there is a further step, you don't need to address the step as a CCP, and again, you can stop. Okay, so guys, the point about this particular model, it's 4 questions as opposed to 3, but again, the focus is primarily on criticality and the CCP, and you'll note that we don't really see any mention of these other control measures that we have, such as general PRPs, operational prerequisites, and so on. Now, of course, it is implied that in the absence of a CCP being determined here, that there may well have to be some other generalized control measure. However, it could be argued that the Codex model is not particularly helpful in identifying that clearly. So, I'm going to move on then, guys, to a more comprehensive model, which addresses all of the control measures that we've previously spoken about. So here we're talking about the CCPs, PRPs, operational prerequisites, control measures, quality control points. So this next model covers all of those requirements off, and by nature is far more complex. But I'm going to take you through it step by step. And again, don't try to understand or absorb it all. You can do that later on. But just get the essence of what's being presented and the fact that you can, in fact, build models that cover off all of these things and indeed more. Okay, so our comprehensive decision tree model starts out with a question. Is there a food safety hazard at this step? So no different from the previous models we've just mentioned. Let's say we say no, there is in fact no food safety hazard at this step. We get a direct output, which is control this as a quality control point if required. So straight away, we're already clearly identifying the appropriate control measure based on question number 1. However, if there is a food safety hazard that requires attention at this step, we're saying yes. We move on to another question, question 2. Do control measures exist for the identified hazard? So you will see similarities already between this and the Codex model. Excuse me. So do control measures exist for the identified hazard? We say no, there are no existing control measures in place. Then we ask the question, similar to Codex, is control necessary? That's question 3. So if you say yes, there is control necessary because there is a hazard that we're concerned about, then the model suggests that you should modify a process, the step, or the product formulation. And then that directs you back into question 2 again. So you can see it's very clear, simple logic, but it's nicely building the things that you need to consider when it comes to determining the control measures that you require. Okay, so let's go back and let's assume that control is not necessary. Well, then we can say, no, it's not a CCP, and we can say stop. No control required. Okay, however, let's say in question 2, because we need to go back up now, do control measures exist for the identified hazard? Yes, they do. So we have control measures in place, which is good. Now we're asking on question 4, again, the exact same question Codex posed. Is the step specifically designed to eliminate or reduce the likely occurrence of the hazard to an acceptable level? 2 possible answers here. The first of them is yes, and that straight away tells us it needs to be controlled as a CCP. Okay, so this is a very useful model. It's already now telling us whether we need to control it as a quality control point or as a CCP. However, if the step is not designed to eliminate or reduce the hazard to an acceptable level, no. We ask the same question again, such as Codex, could contamination occur or increase to an unacceptable level? Let's say the answer is no, then again, we can stop. No control measures are required here. If the answer is yes, contamination could occur, we ask question number 6. Will a subsequent step eliminate or reduce the hazard to an acceptable level? So you can see so far, guys, here we've effectively followed the Codex decision model. So we haven't reinvented the wheel here in any shape or form. We're just using what most of you are familiar with. So a subsequent step later on, yes, there is a subsequent step, so therefore we do not need to apply any further controls at this step because later on, a step will sort out this particular issue for us. However, if there is no subsequent step to address the issue, we move on and answer question 7. Okay, so actually, guys, I think I might have, yeah. So will a subsequent step eliminate or reduce the hazard to acceptable level? No. In that case, now there's a slight difference here. If the answer is no, it will go to control as a CCP. However, if there is a subsequent step, so sorry guys, there's a slight error there. I should have actually said action. Will a subsequent action eliminate or reduce it to acceptable level? So I'll adjust that in the copy sent out to you. So apologies for that. So just explain the difference. In this question 6, we're looking at step. However, in question 7, we should be talking about a particular action or other intervention you can make aside from a process step. So will a subsequent step eliminate or a subsequent action eliminate or reduce the hazard to an acceptable level? No, then it has to be a CCP. But if there is a subsequent action you can take, then we ask question 8, is this action specific to a particular step in the process, as opposed to a general action that you might take? So if the answer is no, then it's a general action or PRP, like cleaning or pest control. However, if the subsequent action you can take is specific to the process step, then you control it as an operational prerequisite program. So what we've done here is we've combined both the Codex decision tree with the requirements that the ISO 22000 brings in, speaking about the operational prerequisite program. And then we also then put into the model how we clearly identify general prerequisite programs too. Okay, so guys, this model kind of encapsulates the other models, and key point is it addresses all the potential control measures that you may select from in addressing the particular hazard. Okay, so we're almost finished. So I just want to summarize some of the key points. Very important. Don't get too preoccupied with the terminology around control measures. So, I mean, I've sat through many audits that I've conducted, and indeed meetings as part of HACCP teams, where there have been endless debates and discussions, sometimes quite fiery ones, about whether something should be called a CCP or an operational PRP. Very often my unspoken opinion of it was, well, it doesn't really matter. As long as we put in place the appropriate control, what we choose to call it is actually quite irrelevant. As long as it's effective and it's validated and appropriate for the hazard and the risk that we've identified. Just another point there, always select the appropriate control for the hazard and the risk presented. That's very important. Your risk assessment is crucial. You must do it well, and you must do it clearly. And you must identify the significance, because that then determines and dictates the level of control that you need to apply. Recommend that you do use a decision tree model that's appropriate to your needs. So some companies like to take a more sophisticated approach to determining control measures, and that can be for good reason. Maybe they're operating in a very highly regulated market, or the product they're producing is significantly high risk. So there's less scope for getting it wrong. But always pick the one that works best for you, and that obviously meets the needs of your customers and the regulatory environments that you exist within. Okay. The use of risk assessment is important because determination of control is quite a significant consumer of time. So when you have to go through and determine control measures for every single step and hazard in your process, it requires a lot of effort, a lot of time from your HACCP team and other team members. So risk assessment is useful because if you can deem the hazard not to be significant, you are legitimate in your decision not to apply the determination of control. Okay, so that can save you a lot of time and a lot of energy if you use risk assessment correctly. Okay, Simon, that's the presentation now. So any questions? And more than happy to take them at this stage.
Yeah. Okay, thanks very much, George. Lots, like you say, there's always a lot of misunderstanding. If you want to switch your webcam back on, there's always a lot of misunderstanding and lots of questions on the discussion forum about the interpretation of the different CCPs, ORPs, OPRP, all of that, and you've helped us simplify that today. Lots of comments in the sidebar. So if we want to pick, we've got around 10 minutes to pick up some of the questions. Okay, Mark, well, will you discuss radiological hazards as noted in FSMA? Have you got any comments on radiological hazards?
Yeah, well, it's required, specifically mentioned in FSMA, so it should definitely be addressed as part of your PCP plan, if they're there. I'm not sure what other comment I can make beyond it. It should follow the same rules as any hazard analysis and the principles of conducting a study around food safety. Yeah.
Okay. Emily, this is quite early on in the presentation. With the last example, I always wonder, does in the absence of a control go all the way down to if people are not washing their hands?
Yeah, it is a great question, and I suspect that this is coming from FSMA perspective, and the way to deal with that is to actually go back and read the FSMA requirements in detail. So FSMA does mention significant hazards. So I made the point earlier, use the risk assessment to clearly separate out significant from non-significant hazards. You don't need to determine control measures for non-significant hazards. Or in the case of hand washing, that, just on a very high level, would appear to be a general PRP of some sort. So risk assessment is the key to that, and going back to the source, which is FSMA, is saying significant hazards are where preventive controls are required.
Okay, thank you. Flora asked, what are the acceptable levels in control measures?
Okay. So it depends obviously on the hazard identified. So you have to go back to the hazard, and you need to decide based on a study essentially around the hazard, what is the acceptable level? Because it may not be possible to eliminate that hazard, but it may be acceptable at a particular level, and that can flow either from legislation. It can flow from, like Codex Alimentarius have various committees which are set up specifically to look at chemical hazards, biological hazards, and they produce data on what is acceptable, the accepted level of protection, and so on. So it's a question that's impossible to answer. It's a unique answer for every specific hazard that you identify. Yeah.
Okay. Humberto asked, does preventive control always equal CCP? Can you have a preventive control that have not been traditionally CCPs?
Okay, so does preventive control equal CCP all the time? The answer is absolutely not. Preventive controls can mean CCPs, absolutely, but they can also mean more generalized control measures like cleaning, hand washing. If you look at FSMA, for example, it has a prescriptive list of preventive controls, and it includes supplier quality management as a preventive control. So the short answer to the question is no, don't have to be CCPs, and ideally should not be CCPs, because if the more CCPs you have, the more management of them you need to exercise. Yeah.
Okay, the next one, Narongachai, is the OPRP equal to the PRP control measure in the process and look like the sanitation PC or allergen PC in Harp C?
Okay. All right. So, we're talking about Harp C. Sorry, guys. I just need to switch on some power here. 1 second.
Don't be disappearing on us. I know it's a tough question, that one.
Yeah, I had to compose myself for this one. Okay, well, as soon as you mention Harp C, we're talking FSMA, Food Safety Modernization Acts, and in that context, the FSMA does not specifically mention operational prerequisite programs. So I think this is a classic example of how we're cross, fertilizing terminology and trying to match it up and make it all common. So my suggestion is don't even try to do that. Ignore the terminology OP or P if you're operating under Harp C or preventive control plans. Simply follow the guidance given, the requirements of FSMA, and use that terminology. Don't get bogged down in trying to get a square peg into a round hole on this one. Yeah.
Okay. Have you just answered this one in a way? Larby is saying, what is the difference between OPRP and preventive control?
Okay. Again, a preventive control is the term arising out of FSMA, and what FSMA says is that you should apply a preventative control where there's a significant hazard that needs to be addressed. Now, it does give guidance to say that can include a critical control point, but what you call the preventive control other than that doesn't actually matter as long as it's appropriate. So again, on my summary, I said don't get too bogged down in the terminology, because there may not be, you may not be comparing apples with apples, more like apples with oranges. Yeah.
Okay, that's clear. Stuart is referring to an example he gave. Using your example, if a single magnet is not designed to eliminate a hazard, but reduce it, but not to an acceptable level alone, but is part of a series of magnets to accomplish this, then the magnet should be OPRP, correct? Or CP or CCP?
Sorry, Simon, can I ask you just to repeat that? You just broke up during the middle of it. Yeah.
He's referring to an example. Using your example, if a single magnet is not designed to eliminate a hazard, but to reduce it, but not to an acceptable level alone, but is part of a series of magnets to accomplish this, then the magnets should be OPRP. Is that correct? Or should they be CP or CCPs? What should they be? A series of magnets?
I think, again, it's open for debate. It's an open question, but I would suggest that it would be an operational prerequisite program. The use of inline magnets will reduce absolutely the frequency at which the hazard will occur in the final products. That's clear. Is it critical? In other words, if you don't get it absolutely right 100% of the time, say like with sterilization or pasteurization, will it cause issues? And the answer is probably not. It will probably cause some issues and customer complaints in the market for sure. But the question is, at what level? What's acceptable in that case? And the answer to that question will arise from any legal criteria that may be there. You need to find that if it exists. Or it could be in the form of a customer specification where you agree with the customer, if you are supplying to a retailer, what is in fact acceptable a level of metal contamination in that case. But I would suggest a short answer would be that it sounds like an operational prerequisite program to me and not a CCP. But every company must make that determination themselves.
Yeah, that's clear. Abdul Hamid, some decision trees take in consideration the fact that the monitoring should be continuous in order to be a CCP. Otherwise, it will be a PRP. Are you convinced with this?
Well, it kind of operates on the assumption that the technology is available to monitor things on a continuous basis, which may not be the case. And I suppose it goes back to the term where control can be applied. The short answer, ideally, you want continuous monitoring, but that may not be possible for a whole range of reasons. Maybe the technology isn't developed enough to do it. Maybe the company doesn't have the wherewithal to invest in that level of monitoring, and maybe it's not absolutely required to reduce the hazard to a acceptable level. So you could end up over monitoring at significant cost beyond the needs. Yep. But I'm not aware of any specific requirement that it must be continuous. Yeah.
Okay. There are some questions relating to this. Yes, this presentation and the recording will be issued email to all registrants later. You can access the white papers that George. Do you want to explain, George, about the that goes into more detail on this subject on your website?
Yeah, so if you log on to Safe Food 360, at the top level, you'll see a link called Resources, and you can access those white papers which supplement the webinar today. So they're free of charge, just click download and they're yours.
Okay, and we'll put a link to that in the follow-up email. Raquel, is there any software that I can use for the ISO 22000 decision tree to make it a more efficient process?
Yes, so there are there's various software vendors out there, of which we are one, and I would certainly encourage you to contact and research them. Yeah.
Okay. Christine, is there a simple quantitative ranking for hazards that can be used that is somewhat standard?
Yes, again, I'll just maybe direct the questioner to our resource page, and if you scroll down through the list of white papers, you'll see one that actually addresses that specific question.
Right. Tariq, any example of a step where there are no hazards?
No hazards. Yeah, loads. If you're doing it right, yes. Top of my head, I mean, for example, if you're looking at a stage which is finished product packed finished products in the distribution chain, you wouldn't necessarily take account of environmental pathogens, which are not or very unlikely, if at all, to be present in the product, introduced to the product at that stage. So definitely negligible in that case. You can never really say absolutely no, but you can certainly use the term non-identified.
Okay. Human, is metal detector a default CCP for food manufacturing? If someone wished to not have it as a CCP, how can you just validate, prove that, justify it?
Okay, so not a question that you can answer quickly or easily, but well, first of all, going back to the unofficial decision tree, which I showed you, most food retailers will demand that you have end-of-line, metal detection in place as the ideal scenario. They'll very often ask for it to be managed as a critical control point. So in that case, it's pretty straightforward. You'll have to accede to that demand. So the way you would do it is by demonstrating that you have a logic and a decision tree, which clearly drives you to the decision that it's an operational prerequisite program. But again, you need to define that for yourself, and you need to back it up and validate it. But I will make the point: it typically doesn't really matter. In reality, if you can have that debate whether it's a CCP or an OPRP. But the question is, if by changing the name of the control measure, will you actually change the control measure itself? And that's the real test. That's the real asset test. If you move it from a CCP to an OPRP, you should, arguably, be able to reduce the level of control. In other words, check it less or have fewer corrective actions in the event that you get a failure. Yeah.
Okay. Angie, you're just complimenting us on the webinars and asking if there's any FSMA ones coming up. Yes, there is actually. Bill Bremer is here on the 3rd of November. He's going to be talking FSMA and specifically on the Foreign Supplier Verification Programme. And towards the end of November at Food Safety Live, one of the presenters is going to be specialising in FSMA, so you'll be able to ask your questions there. We'll be sending details soon about that. Are microbiological analysis considered a PRP or a CCP? For example, eggs, salmonella analysis considered a PRP?
Can you just read that again, Simon, please?
Are microbiological analysis considered a PRP or a CCP?
Normally, no, they're not. Micro-testing of the products typically is not considered a control measure. It is very widely used as a positive release measure, and that's perfectly fine. But micro-testing, particularly if it's not rapid testing, should not be a CCP for sure. It can be used for, in the form of ATP testing. You can release lines, which could be general control programs for sure. But typically, if you're concerned about the presence of pathogens like salmonella, the control measure, like for example, cooking, is normally monitored on the basis of time and temperature, which is validated to achieve the micro levels that you need. So it's kind of a secondary measure, which probably should not really depend upon. But each to their own. If you can prove it does the job, fair enough.
Okay.
Yeah.
Okay, just a couple more. Marlita, do Safe Food 360 have any white papers on validating metal detectors?
Yes, there's a white paper on the resource page on metal detection. So definitely refer to that. Yeah.
Okay. Al Chapon, if the food additive manufacturer sent their product to the factory who export their product to the USA, does the food additive manufacturer need to implement PCQI for human food? That's a bit off topic, but
slightly off topic, yeah. But if you want to read it once more, I'll do my best.
So we've got a food additive manufacturer sending their products and exporting them to the USA. Does the food additive manufacturer need to implement PCQI for human food?
Okay, so yeah, my understanding is they would. If they're exporting their product to the US, they will fall under the Foreign Supplier Verification Program requirements, and part of that is that they must obviously do risk assessments. They must do everything that's required. And I mean, I'm open to correction on this. I think it has to be done by a PCQI. So.
Right. Okay. On that note, John's saying this webinar was scheduled for 1 hour. Please wrap it up. So
Okay.
I think on that note, we will do. George, as ever, great presentation. I'm sure the audience today and those who watch the recording, when we get the PowerPoint as well, and put that together and look at the resources on Safe Food 360, we'll have a greater understanding of this topic. So thanks for joining us today.
You're more than welcome. Thanks for having me, Simon. Appreciate it.
Yeah. Okay. See you soon.
Okay. Take care.
Okay, ladies and gents, I've already loaded the certificate in the sidebar for today. Just click on that, go to the web page on the right hand side, download it from Dropbox. It's a GIF image. You can either print that and sign your own name on it, or you can open it in a graphics editing package and type your name. I'm sorry, but we cannot personalize for 1,800 people. Okay, hope you've enjoyed today and got something out of it. We'll be back on November the 3rd after a short vacation. We'll be sending you details. We'll send you a follow-up to this with the slides, the recording, etc., and links to Safe Food 360 website. So enjoy the rest of your day. It's Friday. Happy Friday, best day of the week. Enjoy your weekend, and we'll see you soon. Take care.